The surface looks innocent. That's what gets you. You're floating there, sun on your face, water glittering in every direction, and everything feels shallow, safe, known. But directly beneath you, stretching down for kilometers you cannot imagine, something enormous is happening, has always been happening, and it has nothing to do with waves, or tides, or storms. It starts with death, small death, the kind you'd never notice. A single plankton dies. You wouldn't see it happen. It's smaller than a grain of sand. Its entire life lasted maybe a week. It drifted with currents, fed on sunlight, and then, quietly, it stopped. But that's not the end of the story. That's actually where the story begins. Because the moment that tiny creature dies, it starts moving in a direction it never moved before. Down. Not quickly, not with any urgency. It drifts, tilts slightly in the current, catches on a thread of mucus from some other creature nearby, picks up a fragment of shell, a piece of algae, something that was alive this morning and isn't anymore. And together, this little cluster of death begins its journey. Scientists watching through underwater cameras have described it as hypnotic, not frightening, not grim, hypnotic, because it moves the way snow moves through still air, unhurried, weightless in a way that doesn't make sense, turning slowly as it descends. And you realize you're not watching something fall, you're watching something travel. The ocean has layers. Most people know this in a general way, but they've never really felt what it means. The top layer, where sunlight reaches, where fish you recognize live, where the water is warm enough to swim in, that layer is thin, embarrassingly thin. Compared to everything below it, the sunlit zone is a film, a skin, a membrane stretched over something ancient and vast. Beneath it, the temperature drops. Not gradually at first, sharply. There's a boundary layer where warm water meets cold water, and that boundary is so defined that submarines use it to hide. Sound bounces off it. Objects disappear behind it. It's not just a change in temperature. It's almost like a floor with an entire other ocean beneath it. And through that boundary, our tiny cluster keeps moving. It crosses into water that has never been warm. Water that formed in the polar regions centuries ago and sank because cold water is heavier than warm. It has been slowly circulating through the deep ocean ever since, carrying its coldness with it, moving so slowly that a single molecule of water in the deep ocean might not reach the surface again for 1,000 years. Our particle drifts through this ancient water and keeps going down. By the time you reach 500 meters below the surface, color no longer exists. This isn't a poetic statement, it's physics. Seawater absorbs wavelengths of light selectively. Red disappears first, then orange, then yellow. Green lasts longer than most people expect, but by the time you're deep enough, everything becomes blue. And then, the blue fades too. And there is nothing. No color, no shadow, no visual reference for up or down. Just a darkness that is so complete that your eyes, given hours to adjust, would still see nothing. Not even a hint. Not even the ghost of a shape. Total. And yet this is where things get strange. Because this darkness is not empty. It never was. We assumed it was for a long time. It felt logical. No light means no photosynthesis. No photosynthesis means no plants. No plants means no food. No food means nothing. Scientists in the 19th century were so convinced of this logic that they gave the deep ocean a name based on it. The Azoic Zone, the place without life. It seemed obvious. It seemed settled. They were wrong in a way that still humbles biologists today. Because something was falling through that darkness. had been falling through it for hundreds of millions of years, before humans existed, before mammals existed, before the dinosaurs. Since the first single-celled creatures died at the ocean's surface and began their slow descent, the deep ocean has been receiving a delivery, every second, every hour. Through every ice age and warm period and mass extinction, the snow has never stopped. What makes it strange is not just what it's made of, it's what happens to it on the way down. Our cluster doesn't fall alone. Other particles bump into it, stick to it. A fragment of a crustacean shell from something that was eaten 3 weeks ago. Mucus threads secreted by creatures that filter the water for food. Fecal pellets. And I know that sounds unglamorous, but those pellets are actually one of the most important things in the ocean. They're dense. They sink faster than almost anything else, and they carry carbon captured from the atmosphere by tiny plants at the surface, straight to the bottom. The ocean's way of locking away carbon that would otherwise stay in the air. Your breathing is connected to this process. The air you're drawing in right now is partially shaped by what sank to the ocean floor before you were born. But let's stay with the journey, because it takes time, real time. A particle leaving the surface today might not reach the seafloor for 6 months. During those 6 months, it is not alone. It passes through communities of creatures that exist nowhere else on Earth. There's a layer of the ocean, roughly between 200 and 1,000 meters down, where something happens every single day that is one of the largest migrations on the planet, and almost no one on land knows it's occurring. Every dawn, millions of creatures that spent the night feeding near the surface begin to descend. They move downward to avoid predators in the now lit water above. They spend the daylight hours in the dim cold, waiting. And every dusk, they rise again. This daily migration, this enormous vertical pulse of life, moves through the exact same water column where our snow is falling. The creatures brush past the particles. Some eat them. Some are eating the creatures eating them. The snow becomes part of a web so intricate that scientists have spent careers just trying to map small sections of it. Now picture this from above, from space. A satellite looking down at the ocean sees color, patches of green and blue that shift with the seasons. Those patches are blooms of phytoplankton, microscopic plant-like organisms that use sunlight to grow, the way a forest does, except the forest is invisible and covers more of the earth than all land combined. When those blooms peak, when the surface is thick with life, the snow intensifies. More death means more material to fall, and the ocean floor, thousands of meters below, receives a pulse, a seasonal delivery, an echo of summer arriving in permanent winter. Scientists have measured this. They've placed sediment traps in the deep ocean, like buckets catching rainfall, and watched the snow intensify weeks after a bloom on the surface above. The deep ocean is slow, but it listens. There's something about the midnight zone that took me a long time to fully absorb. It sits between 1,000 and 4,000 meters below the surface. No sunlight, no warmth. Pressure so intense that it would collapse your lungs before you had time to register what was happening. And it is crowded. Not crowded the way a city is crowded the way a dream is crowded, full of things that shouldn't exist, things that evolution built without the usual rule book. Because when you remove light from an ecosystem, every assumption about how life works has to be rebuilt from scratch. There are fish here with eyes the size of dinner plates, not to see clearly, but to catch the absolute last photon of light, in water where a photon is an event. There are fish with no eyes at all, who navigate entirely through pressure changes and electrical fields. There are creatures so transparent that looking at them directly, you're looking through them. Their organs visible, their hearts beating, their last meal visible in their stomach, like an exhibit behind glass. Evolution removed their pigment because pigment costs energy, and in a place where food is scarce and unpredictable, you don't spend energy on anything that isn't survival. And then there's the light. I want to stay on this for a moment, because it changes something in how you see the dark. Most creatures in the midnight zone produce their own bioluminescence. Not all of them, but most. Which means, in a place with no sunlight, there is still light. Strange light. Living light. A deep-sea fish opens its mouth, and the inside glows with blue-white points, like a trap made of stars. A squid flashes patterns across its skin, communicating in a language that has no words. A jellyfish trails curtains of cold green fire for reasons scientists are still debating. The darkness down there isn't dark the way we imagine darkness. It's punctuated, interrupted by flashes and glows and pulses that happen and disappear with no one watching, until now. Through all of this, our particle keeps moving. It's smaller now than when it started. Things have fed on it. Bacteria have broken pieces away. But the core of it remains, and it carries something that most people never think about. It carries carbon, captured from the atmosphere months ago by a photosynthetic organism at the surface, converted into organic material, passed through the food web, and now being carried to the seafloor, where it will be buried, removed from circulation, locked away. This process has a name, the biological carbon pump, and it is one of the primary reasons that Earth's atmosphere contains enough oxygen for you to breathe right now. The ocean has been running this pump for longer than complex life has existed on land. Every breath you take is downstream of a particle falling in the dark. We need to talk about time differently for a moment, because the deep ocean operates on timescales that make human history feel like a heartbeat. The sediment on the seafloor, the compressed layers of marine snow that have accumulated over millions of years, is a record. Not a metaphor for a record, an actual archive. When scientists drill into that sediment, they extract cores, cylinders of compressed history, and they read them the way a geologist reads rock strata, except this record is finer, more detailed. A single centimeter of sediment might represent thousands of years, and every centimeter tells a story. A warm period when certain species thrived, a cold snap when different organisms dominated the surface. The moment, 66 million years ago, when an asteroid struck the Earth. You can see it in the sediment. A thin layer, a boundary, where the snow changes completely. Above it, the aftermath. Below it, a world that no longer exists. The snow recorded the end of the dinosaurs. It recorded every ice age, every warm interglacial, every shift in ocean chemistry, every change in what lived at the surface, and what died and fell. Here is the part that stays with me. Right now, tonight, the ocean is recording this moment, your moment. Not you as an individual, but the era. The chemistry of the air you breathe is different from the air of 100 years ago. The ocean's surface is warmer. The species composition of the phytoplankton is shifting. The snow itself is changing. Different particles, different densities, different rates of descent. And all of that is being written into the sediment, right now, as you listen. Millions of years from now, if something intelligent reads those layers, they will find a boundary, a moment when something changed, when the chemistry shifted suddenly, when certain species vanished, when the snow transformed. They will find us, not our buildings, not our languages, not anything we think of as our legacy. They'll find the echo of us in the deep ocean sediment, written in the language of falling things. We've come a long way tonight, from the surface, through the fading light, through the cold boundary waters, through the living darkness of the midnight zone, and we're approaching something, a place most humans will never see, where the snow finally arrives, where creatures have been waiting, in total darkness, at pressures that compress the water itself, for a delivery that takes 6 months to arrive. And what lives there? What survives there? What has been surviving there for longer than our species has existed is something that changed everything. Scientists thought they understood about the requirements for life. Not just ocean life, all life, everywhere in the universe. That story is waiting just below us. The floor is close now, and the snow is still falling toward it. Stay with us. The floor is close now. At first, you would not see it clearly, even with a light. Even inside a deep-sea vehicle, with thick glass in front of your face, and instruments telling you exactly how far down you are, the bottom would not appear like land appears. There is no shoreline, no clear edge, no dramatic wall rising out of the dark. Only particles, a slow gray haze, tiny pieces drifting past the lights, so many of them that the water itself begins to look dusty. Then the darkness ahead becomes slightly heavier. The black stops feeling endless. A shape forms where there was no shape before. And after months of falling, after crossing kilometers of cold water, after passing through the last traces of sunlight, the snow reaches the seafloor. It does not crash. It does not scatter like ash from a fire. It lands softly, a small piece of death, settling onto a plain larger than any desert on Earth. And down here, that tiny landing matters. Because the deep seafloor is not waiting for sunlight, it is waiting for what falls. The abyssal plain is one of the most misunderstood landscapes on the planet. It sounds empty. That is the mistake. When we hear the word plain, we imagine something flat, silent, almost unfinished. But the abyss is not an empty floor. It is a slow world, covered in fine sediment, old shells, volcanic dust, bacterial films, and the remains of things that once lived far above. The surface of the mud is soft, almost powdery in places. A machine touching it too hard can erase patterns that took years to form. A fish passing low over it can leave a faint trail. A sea cucumber can move through it like a living vacuum, swallowing the sediment, digesting whatever organic material it can find, and leaving cleaner mud behind. That is how scarce food is down here. Down here, even dirt can be food. At first glance, the animals of the abyss do not look busy. They do not move like reef fish. They do not flash between coral. They do not chase sunlight, because sunlight is not part of their world. Everything is slower here. A sea cucumber may spend its life crossing the same dark plain, mouth pressed to the sediment, taking in mud one mouthful at a time. A brittle star spreads its thin arms across the floor, waiting for particles to touch them. Small crustaceans move through the silt carefully, as if every step costs something. Worms live inside the sediment itself, in tunnels so small and delicate that one careless sample scoop could destroy an entire hidden neighborhood. And above them, the snow keeps arriving. Not enough to make life easy, but enough to keep life possible. That is the first real shock of the abyss. The deep sea floor is not empty. It is hungry. That hunger shapes almost everything. Bodies grow slowly. Movement is expensive. A mistake costs energy that may not be replaced for a long time. Even reproduction has to fit a world where food does not arrive on command. Sometimes the snow falls thin for weeks. Then a bloom at the surface dies, or a storm mixes nutrients into sunlit water, or a seasonal shift creates a burst of plankton above. And months later, the abyss receives the message, not as light, not as warmth, as food. The deep ocean gets news from the surface in the form of falling bodies. When scientists placed cameras on the deep sea floor, they expected patience. They expected long recordings where almost nothing happened. And sometimes, that is exactly what they saw. Hours of dark mud, a few animals moving slowly through the frame, marine snow drifting down like dust in an abandoned room. But then, something changed. A pulse of fresher material reached the bottom. The sediment looked different. Animals arrived. Sea cucumbers gathered where the new food settled. Brittle stars shifted position. Tiny organisms hidden in the mud became active. The deep did not wake up loudly. It adjusted. It responded. That is what makes this world so strange. The surface can bloom in sunlight, and the abyss can answer months later in total darkness. Most of the snow never makes it this far. That part matters. The journey down is not just a fall. It is a long feeding event. Bacteria break particles apart. Tiny animals eat them. Larger animals eat the animals feeding on them. Some particles dissolve before they reach the deep. Others are torn apart, repackaged, swallowed, released again, and sent lower in a different form. By the time marine snow arrives at the seafloor, it has already passed through a living filter. What lands down here is not the original surface world. It is what survived the descent. A reduced version, a changed version, a message rewritten by every mouth it passed. And still, it supports life across enormous areas of the planet. The largest habitat on Earth is fed by falling death. There are moments when the snow becomes visible in a way that feels almost wrong. A camera light turns on, and the water fills with flakes. Some are large enough to see as individual clumps. Others are so fine, they blur into a pale mist. The vehicle moves forward, and the snow appears to rush toward the lens, even though most of it is barely moving. For a moment, the deep ocean stops looking like water. It looks like space, a dark field filled with slow debris. But every piece has a history. One particle might contain the remains of a diatom, a glass-shelled organism that once floated near the surface. Another might carry bacteria growing on mucus. A third could be part of a tiny animal that was eaten, digested, and released back into the water column. There is nothing clean about marine snow. That is exactly why it matters. It is messy life, becoming food, becoming sediment, becoming climate history. Now imagine being an animal down here. You do not know the sun. You do not know the season directly. There is no morning. There is no evening. Weather never reaches you as weather. The only sign that something changed above is what falls into your world. If more food lands, you move. If less arrives, you wait. Your body cannot waste effort chasing what may never come. So evolution makes you patient. It makes you efficient. It gives you slow digestion, low metabolism, soft bodies, strange mouths, long sensory organs, and behaviors that would seem passive anywhere else. But down here, patience is not weakness. It is survival. A creature that burns energy too quickly does not look powerful for long. It simply disappears. Some deep-sea animals have become specialists at catching falling food before it even reaches the mud. Transparent creatures drift above the floor, waiting in the water like glass traps. Jelly-like animals spread feeding structures into the current. Small crustaceans intercept particles and pull them apart with delicate limbs. A piece of marine snow may fall for months, only to be eaten a few meters before it touches the bottom. That sounds almost cruel, but the abyss does not waste. A particle is not always one meal. It can become many meals, inside many bodies, at many depths, before the last fragment settles. The deep ocean is not a straight path from death to burial. It is a slow recycling system, so large that the planet's atmosphere is tied to it. This is where the story becomes bigger than the seafloor. Marine snow is not only feeding animals, it is moving carbon. At the surface, tiny photosynthetic organisms pull carbon dioxide from the water. That carbon originally came from the air. They use sunlight and turn it into living tissue. For a while, that carbon is part of a body. Then the body dies, or it gets eaten, or it becomes waste. If that material stays near the surface, bacteria can break it down quickly. Much of the carbon returns to the water and eventually moves back toward the atmosphere. But when some of it sinks deep enough, the story changes. The carbon is carried away from the surface. It enters cold water, slow water, old water, and if it reaches the sediment, some of it can be buried. Not all of it, not even most of it, but enough. Across huge spans of time, that buried fraction becomes one of the quiet forces that helps regulate Earth's climate. The deep ocean does not look powerful. That is misleading. It can change the air by hiding what used to be alive. There is something strange and almost uncomfortable in that. The breath inside your lungs, the temperature of the world you were born into, the balance of gases in the atmosphere. All of it is connected to processes happening in darkness, far below ships, far below storms, far below almost every human story. A plankton bloom at the surface, a particle falling for months, a sea cucumber digesting old organic matter, a thin layer of sediment forming so slowly that no person could watch it grow. These things sound small. They are not small when they happen everywhere. They are not small when they continue for millions of years. The deep ocean works by accumulation. That is its power. It does not need to be fast. It only needs to continue. And it has continued for an almost unimaginable length of time. Long before humans walked upright, marine snow was falling. Before forests covered continents, it was falling. Before dinosaurs moved across land, before flowers existed, before the first animals crawled onto shore, the ocean was already turning life at the surface into food for the deep. Every era left something behind, not as a monument, as sediment. Layer after layer of microscopic remains, settling, compressing, holding chemical clues that scientists can still read. The seafloor is not just a place where things end. It is one of Earth's memory systems, a dark archive built from falling particles. The planet does not throw death away. It files it. When researchers drill into deep-sea sediment, they are not just collecting mud. They are pulling up time. The core comes out as a cylinder, ordinary looking at first, but inside it, the history of the ocean is stacked in order. Younger material near the top, older material below. Each layer contains fossils too small to notice with the naked eye. Shells of plankton, mineral grains, chemical ratios, traces of oxygen, carbon, temperature, ice volume, volcanic ash, dust from continents, and signs of sudden disaster. The ocean floor keeps receipts, quietly, patiently, without caring whether anyone will ever read them. One of the most haunting things preserved in these layers is the boundary from 66 million years ago. The day an asteroid struck Earth was not only recorded in fire, impact glass, and shocked rock. It reached the ocean too. At the surface, ecosystems collapsed. Plankton communities changed. The rain of particles into the deep shifted. And in seafloor sediment, scientists can find a thin line, a chemical and fossil break between one world and the next. Below that boundary, there was the old ocean. Above it, there was the aftermath. The snow changed because life changed. A disaster in the sky became a line in the mud. The same archive holds traces of ice ages. During colder periods, ocean circulation changed. Surface life shifted. Dust from dry continents blew over the sea. Tiny organisms built shells with chemical signatures from the water they lived in. When those organisms died, their remains fell. No one designed it as a record. No creature meant to leave a message. But evidence was made anyway. A slow record built from bodies. Every warm period, every cooling, every major change in ocean chemistry left some kind of mark. The deep ocean did not witness these events with eyes. It received them. It stored them. And because it stored them, we can look backward into versions of Earth that no longer exist. This is why marine snow changes in your mind the longer you think about it. At first, it sounds like a strange natural effect. Dead things falling through water. Then it becomes food. Then climate. Then history. By the time you reach the seafloor, you realize the snow is not a small detail of the ocean. It is one of the ways Earth connects its worlds. The bright surface touches the dark abyss through it. The atmosphere touches the mud through it. The living world becomes part of the dead one, and the dead world feeds life again. That is the quiet shock of it. The ocean does not keep these things separate. It moves them into each other. But the seafloor is not only fed by slow flakes. Sometimes, something much larger falls. A fish dies and sinks. A squid is torn apart above the bottom. A jellyfish collapses into the dark. And sometimes, a whale dies. For a whale, the descent is different. Its body may fall thousands of meters, carrying tons of organic matter, into a place where meals usually arrive as dust. When it reaches the seafloor, the entire neighborhood changes. Scavengers detect it. Hagfish arrive. Sharks may appear. Amphipods gather in dense numbers. The soft tissue is stripped away. Later, worms and bacteria work on the bones. Chemicals released from the skeleton feed communities that can last for years. A whale fall is not just a dead animal. Down here, it is an event. A temporary city built around one body. That helps explain the scale of hunger in the abyss. A single large carcass can support life for years because the normal rain of food is so thin. Marine snow is steady, but it is not generous. It feeds the background world. It keeps the slow systems alive. Then, rare falls, fish, squid, wood, kelp, whales, create brief islands of abundance. Life down here has learned to wait for both, the constant dust and the sudden feast. That combination creates a world that is neither empty nor rich. It is balanced on patience. And patience, in the abyss, can look almost like death until the food arrives. And still, even this is not the whole story. For a long time, scientists believed that nearly all life in the deep sea depended on the surface. That made sense. Sunlight feeds plankton. Plankton feed the snow. The snow feeds the deep. A simple chain from light to darkness. Then deep-sea exploration found something that broke the old picture. Hydrothermal vents. Places where seawater sinks into cracks in the crust, heats near magma, reacts with rock, and erupts back into the ocean, loaded with chemicals. Around these vents, life does not wait for marine snow in the same way. Bacteria use chemical energy. Animals feed on those bacteria or live with them inside their tissues. Giant tube worms, clams, shrimp, crabs. Entire communities built around chemistry, not sunlight. That discovery changed biology. It showed that life could be powered by more than the sun. And suddenly, the deep ocean was not just a remote place on Earth. It became a clue for where life might exist elsewhere. Under the ice of Europa, inside the ocean of Enceladus, maybe in places with no surface sunlight at all. The deep sea did not just change ocean science. It changed the way we imagine life in the universe. But away from the vents, across the wide abyssal plains, the snow remains the old delivery system, the quiet one. No black smokers, no dramatic towers, no glowing mineral chimneys, just darkness, mud, slow animals, and a rain of organic matter from above. That contrast matters. The deep sea is not one world. It is many worlds stitched together. Some are powered by chemicals rising from below. Most are still tied to the surface by the falling remains of life that once touched sunlight. So even in a place that never sees day, the sun is present indirectly, a memory of sunlight arriving as food. Now think about the particle we followed. It began as something almost invisible, a dead plankton, a fragment of shell, a thread of mucus, waste from a creature drifting near the surface. During its descent, it changed. Bacteria colonized it. Animals bit pieces away. Currents carried it sideways. Other fragments joined it. It may have been swallowed and released again. By the time it reached the bottom, it was no longer one clean thing. It was a small, moving history of the water above. Then it landed. Maybe a sea cucumber found it within hours. Maybe bacteria consumed it slowly. Maybe it mixed into the sediment. If buried deeply enough, a tiny part of its carbon might remain there, long after the body that made it disappeared. That is the scale shift this story asks from us. A particle can be almost nothing to the eye and still become part of the planet's memory. There is another detail that makes this more unsettling. The snow is changing. Not in some distant future, now. As the surface ocean warms, as acidity changes, as oxygen levels shift, as plankton communities move, the material falling into the deep changes with it. Some particles may sink differently. Some may be eaten at different depths. Some ecosystems may receive less food. Others may receive pulses at the wrong time. The deep ocean looks isolated, but it is not protected from the surface. It is delayed. That delay can fool us. A change happens above, and the abyss answers later. Weeks later, months later, sometimes across longer cycles. But the answer comes. The deep sea is slow, not safe from us. This means the seafloor is recording us right now. Not our names, not our voices, not the shape of our cities. Something more basic. Chemistry, temperature, carbon, plastic fragments, industrial particles, changes in species, a shift in what falls, how fast it falls, and what reaches the mud. Millions of years from now, if anyone reads these sediments, they may not need our monuments. The ocean will have kept a quieter record, a layer where the chemistry bends, where the shells change, where certain traces appear too suddenly, where the snow no longer looks like the snow before it. That is a strange kind of legacy. Not heroic, not flattering, but real. The deep sea does not care what we meant to leave behind. It records what actually entered the water. And somewhere above all of this, the surface still looks innocent. Sunlight on small waves, a boat crossing a blue horizon, people swimming, never imagining that below them, the planet is moving matter through one of its oldest systems. At the surface, the ocean can seem like scenery. From below, it is a machine of transformation. Life becomes particles. Particles become food. Food becomes bodies. Bodies become sediment. Sediment becomes archive. And the archive waits in darkness until something curious enough or desperate enough comes down to read it. That is why the phrase marine snow is almost too gentle. It sounds soft, beautiful, a little harmless. But the real thing is deeper than that. It is death made useful. It is sunlight carried into darkness. It is the atmosphere touching the seafloor. It is a meal, a climate process, a burial system, and a history book, all happening at the speed of a falling flake. No cloud creates it. No winter controls it. No human eye is needed for it to continue. Most of it happens beyond sight, beyond weather, beyond the part of the ocean we usually imagine. And yet, it is connected to everything. So when you picture the deep ocean now, do not imagine empty black water. Imagine distance, pressure, cold so stable it feels ancient. Then add motion. Slow particles descending through kilometers of dark. Animals waiting below, not frozen in place, but tuned to a rhythm older than our calendars. A sea cucumber crossing the mud, a brittle star lifting one arm into the current, bacteria gathering around a fresh fragment, a camera light catching the flakes for a few seconds before they vanish back into black water. This is not a dead world. It is a world that learned to live on what falls. And the snow is still falling. Above it, storms move across the surface. Ships pass. Sunlight warms the top few meters. Plankton bloom. Creatures feed. Bodies break apart. The next particles begin their descent. Some will be eaten before they reach the midnight zone. Some will sink for weeks. A few will travel for months. An even smaller fraction will reach the bottom and become part of something much older than themselves. The fall never becomes dramatic. That may be why it is so easy to miss. The ocean does not announce the process. It simply continues, quietly, patiently, all over the planet. One day, a particle that began near the surface tonight will land on the abyssal floor. By then, the wave above it will be gone. The weather that stirred the water will be gone. The plankton bloom that produced it will be gone. Whatever creature first touched it, whatever current carried it, whatever mouth almost swallowed it, all of that will have passed. But the particle will arrive, softly, into the dark. And something down there, something slow, something pale, something built for a world without sunrise, may find it. That animal will not know the surface. It will not know clouds. It will not know that far above, someone once looked at the sea and thought the story ended at the waves. For the creature on the seafloor, the story begins when the snow arrives. And that is the secret hidden inside this strange ocean snowfall. It is not weather. It is not scenery. And it is not only death. It is the way the bright world feeds the dark one, the way the planet buries its past, the way a breath at the surface can be connected to mud thousands of meters below, the way life keeps moving even after it stops living. So tonight, somewhere in the deep ocean, far below the last blue light, far below the reach of storms, far below every cloud that will ever form, the snow is falling. It is falling from life itself, and at the bottom, in the oldest darkness on earth, something is waiting. Not for the sun, not for morning, not for the world above to notice, only for the next piece to arrive.